Hey guys, so this is your last video for the last Excel workshop in this series, and I'm now on the Measurements tab. Okay, so this is the data we used last time to calculate some averages. We did some pivot tables if you got all the way to the extra task. We calculated sort of overall averages of students, height and arm span. Okay, and now I want to demonstrate what I talked about before, which is to do with the distribution of data, the shape it takes in a histogram, as well as what happens with when you have outliers in data sets to the different measures of central tendency and dispersion. So if you scroll with me over to the right, I've prepared something here for you. Okay, what you've got there is a few sort of summary data of the height and arm span of people. We've got average, median, we've got the standard deviation. I calculated the interquartile range, and if you remember, that's quartile 3 minus quartile 1. So I've just done all of that in one go. And you can do that, you can combine formulas in cells like this. So calculating first quartile 3, then quartile 1, and then just putting a minus in between them, and it gives you an interquartile range. I've also calculated the minimum and the maximum for the height and for the arm span. And what I've then done is I've created a histogram. Okay, I can really quickly show you how I did that. I'll get rid of this one. And you literally just highlight the range that you want to include. Okay, so in this case that was for the heights. Ooh. Finish at the last one. This last cell here actually gives you an average, so just finish at the last actual entry, which should have all of that information as well. So this is the range you want to include, and then you go insert, and the histogram is this one here. Okay, and that gives you the distribution of data. Okay, so that's all I did. I then moved that over here. Let's bring it over to this side so I can show you a couple of things. Okay. So this is the histogram for the heights, and I've just changed the title of this just for myself really, so I know what it shows. Height in centimeters. Underneath I've also done the same for arm span. Okay, I'll just get rid of this. Right, so what I want to show you is what happens when you introduce outliers into a data set. Okay, so we know that the minimum value in the dataset for height is 149 centimeters, and the maximum value is 197. We know that the average height of people in that course is 173.04 roughly, and the median is 172. We know that the standard deviation is 9.23 and the interquartile range is 11.25. Now what I want to do is just mess with the data. Okay. So if we go over here and we can see our height data, actually you might want to just quickly delete this row right here, the ratio. Just let's delete that so we can bring these things a little bit closer. Okay, that's better. So now all of these things are just a little bit closer to us. Okay, so now we can see the actual data here. These are the different entries, and we can see our summary here as well as our histogram. And what I want to do with you now is to show you what happens when we introduce outliers. Okay, so let's take a value that's somewhere close-ish to the average. Okay, let's say, for example, 170, this one right here. And we want to change this to a value that's going to be an outlier or an extreme value. And I explained before that an outlier or an extreme value is a value that is lower or higher than the other values in the data set. So for example, we know that the minimum value is 149. So let's change this 170 to something which is much lower than that. So for example, let's go with 130. Okay, so what I'm doing here is I'm changing the data. And what happens if I press enter is everything that I've done based on this is also going to change. Okay, so as you've seen, the histogram has now changed because we have this outlier on the left-hand side. So what we've now got is almost like a tail. Okay, so if you draw a curve over the side of this data set now, there's a very definitive tail to the left-hand side. That's what we call a negative skew. The other thing that has happened is these values have changed. And let me show you what's happened. I'll go back to the original state. We had a mean of 173.04 roughly. Now if I change that to 130, that value, we now have a mean of 172.75. So the mean has decreased because I've introduced a small outlier, a value that's extremely smaller than the rest. The mean has changed. Obviously the minimum is now 130 because that's the value I've introduced as the new minimum. Okay, so the average has decreased. The average is affected by extreme outliers and it gets pulled and changed into the direction of the outlier. Look at the median. Original and changed data. The median is exactly the same. It doesn't change. Okay. The other thing is, let's have a look at the standard deviation. In the original state of the data, it's 9.23. We introduce this very small value and the standard deviation increases, okay? We have an increase in variation around the mean because we now have this extreme value and it affects the average distance of each value from the mean, which is what the standard deviation shows. So whether you introduce a small outlier or a large one, the standard deviation increases. Look at the interquartile range. It stays relatively strong, okay? It doesn't change very much. So that's why the median and interquartile range are better to use for skewed data sets because they're less affected. We can also go the opposite way, okay? So let's introduce a value that's much higher than our maximum. So let's say, for example, we change the same value here to 220 centimeters and see what happens. So now our maximum is obviously 220. We have changed the histogram, and now what's happened is the outliers on the right, so towards the higher end of our bins here, of the sort of categories of heights, and that means now the tail is on this side. We call this a positive skew. Okay, so the curve is sort of has this form where it tails off towards the right. What's also happened is that the average has changed from previously 173.04 in the original state of the data set to 173.38 or 39 actually, okay? So it's increased. However, if you look at the median, it hasn't changed at all, okay? The standard deviation from the original 9.23 has increased. Okay, so whether you introduce a small outlier or a large one, the standard deviation increases. Okay, the variation around the mean is higher now. Now in this case, actually the interquartile range has also changed because this outlier so far, it's probably been excluded from the calculations, and so this has now changed actually quite dramatically. But obviously the interquartile range also shows the variation, the spread of the data, and the spread of the data has increased by this outlier. You might remember last week we also produced this scatter graph, and just like everything else, this is the original. If I introduce this outlier, it appears on the scatter graph. That's the point right there, okay? 220 and 166. Now, that's really far from the rest of the data. So if you looked at this pattern, which is what we do when we produce scatter graphs, we can see patterns in the data. You would look at this value and go, what's happened here? You know, this must be a mistake. And I actually think there's a value down here as well where someone said that their arm span was 130 and their height was 168. I believe that also to be a mistake. So these two values here are clearly outliers. And you would probably, if this was real data that you've collected about an animal, for example, or a group of animals, you would probably question whether there was something wrong with either the way you collected the data or with the animal itself. Okay? But most importantly, what I wanted to demonstrate is the reason why we use averages and standard deviations when we have data without a skew, data that follow this nice normal distribution, a symmetrical curve over this pattern here that we see in a histogram, whereas when we introduce outliers, either a large outlier like this, and we produce this tail on the right-hand side that's called a positive skew, then those values, the average and the standard deviation, are affected by it, whereas the median is a more reliable central tendency to describe this data because it doesn't change with outliers. And the same goes when we introduce a small outlier. For example, instead of the 220, we introduce the 130 like we did before. Again, we have an increase in spread, a decrease in the average, but the median has stayed pretty much, well, actually exactly the same. However, we've now produced this left-hand tail on our graph, so we have a negative skew. Now, this will be explained again later on in the module, but just to demonstrate what happens and why we use means and standard deviations for unskewed data and medians and interquartile ranges for skewed data, it's because the mean and standard deviation are affected by outliers and the median is not.